Hello, Assalamualaikum and good morning. So today I will be talking about my mini project, my ALU or ALU arithmetic logic unit. So right now I will be talking about the design module coding. So from line 1 till line 8, this is where I'll be declaring my input and output and also flag. So firstly, on input, I have three input, two main input, which is the 16-bit because this is a 16-bit CPU, A and B, and then I have another input which will be used in my multiplexer as my or like selector, which is 3-bit, my output, which will be used to declare the operation. Next, I have three output, which is one main output and two flag. The first output is result or the output, which is 16-bit. And then I have two flag, which is carry and 0. And for line 11, this rack bracket 16 um, 0 temp is something I declare for overflow. What I mean by this is my my CPU is 16-bit, but whenever there's like, for example, if the input is going to be above 16-bit, there will be an extra bit. So this is where the extra bit goes. This is like temporary storage to see if there is an extra bit or not. And then next I have this always add in bracket star begin. This is just a way for me to tell the compiler this is a logic block combination, which while the star symbol is telling the software to always refresh and recheck the input if there is any changes, if I decided to change it. And then I set carry as 1 bit, value 0 at the top of the coding before the case opcode. And then I started doing my multiplexer or selection, which I will be using case opcode. So I have addition, subtraction, NOR, XNOR, not, increment, rotate left, swap 8-bit as my arithmetic and logic unit. So firstly, I set my opcode to 000 for addition, and the equation is a plus b, and this is the input and the way it works and the equation. And then there's two output. One is the real output, which is 16-bit, and this is the carry output for the flag, which is 17-bit. And then next I have subtraction. I set the opcode to 001. The equation for the input is a minus b, or you can also type it as a plus, in bracket, this wiggle symbol, b plus 1 bracket. It also means the same thing as a minus b, but this is like how computer usually do the subtraction, because ALU usually use full adder for both addition and subtraction. So there is no negative deduction. They use a, and For B, they use second complement. That's why it's not B inverted. It invert the B input first, and then they add +1 at the bit. Then I have NOR, which is my opcode is 010, and this is the equation, not A or B. For XNOR, exclusive not OR, my opcode is 011. The result for the output is not A, exclusive B, exclusive or B. For not, it's just the bigger symbol and then A. For not and increment, there's only one input. Only one input. For the rest, it use two input. Sorry, for not increment, rotate left, and swap 8-bit, it uses one input, which is A. For increment, it's just the input of A plus 1, and then I set the result to 16-bit. But if there is any carry, when the input is like FFF plus 1, it will go to 1000, which is 17-bit. So it will see to check if there is an extra bit. So for rotate left and swap 8-bit, I use this style. For the rotate left opcode is 110 and the swap 8-bit is 111. So for the rotate left, since I will be rotating the left side, I use this bracket to like cut and slice it into a few partition, which I have the first partition as 14 to 0, which means 0 to 14, and then the last bit is 15, the last bit. So basically it will rotate the 15 to the back. Rotate it. I use the same style for swap 8-bit, but since swap 8-bit is like half, I use this this bracket, then I just split it in half. The first part is A720 and then A5028, and then it will swap to the other side. Like this part will go here and then this part will go here. Same goes like this. Next is I have this default begin. Basically default begin means like if the case block isn't starting condition, like if the opcode that it goes into the ALU is like has an issue like error, the default will actually like catch the error, so the CPU doesn't crash or freeze. And lastly, I have this assign 0 result 16B0, which means just I set the 0 to 16-bit. Basically I set if like the output of a waveform is all 0, it will toggle the 0 flag to 1. But if the entire bit is not 0, it will not toggle. That's for my design module. Next, I will be talking about the test bench. So for the test bench, it will be short and simple. So this is like the time scale 1ns, 1ps, basically the reference time unit and time precision. So, and then this part here is like I declare the input and output just like the test bench, but the difference here is there's no bracket over here like design module here. I don't have the bracket. Here and here. I don't have the bracket because it's like self-contained, so it doesn't need it. Next, I do this is instantiate allo. It basically means like I'm just recalling the pod from design module, like while you're jumping it. And then I started with the real test. Here I declare my A input as in hexadecimal 0008 and my B input as hexadecimal 005 all in 16-bit. So the rest is this is I do my addition, this is I do my subtract because 000 001 I already set it on design module and the list goes on. I just do that. Except for zero flag test, get flag test, I do this differently because my original input will not toggle it, so I do it differently. So for zero flag test, I do 5 minus 5, which will toggle the zero flag. And then for the carry flag, I use FFFF plus 1, which will get 10000, which will toggle the carry flag. So now I will run the simulation. Hello underscore TB. Okay, so now I will show the waveform. I will show you the waveform. I'm gonna show the waveform now. So I will run 200 ns. Hello. Okay. Okay, so my audio got cut off. But to summarize, here I was explaining about how the waveform works. There's A input and B input, which I already set, and then there's the operand code, and then there's the result, which is the output. But here I was showing the flag, the zero flag and the carry flag. Since the zero flag and carry flag, I made a different input because my original input cannot toggle the flag. So I did it separately. I use FFFF plus 1 for my carry flag to be shown, and then I use 5 minus 5 to show the 0 flag to be shown. And that's all for me. So thank you.